All right, so we just talked about concave mirrors, but what about convex mirrors? Okay, a convex mirror is a mirror whose reflecting surface curves outward. Okay, so if we look over here, okay, we have our sphere right here. Remember how I said it, pretend like these mirrors form a sphere, and our opaque side is on the inside of the sphere. Okay, so that means our center of curvature is in the middle, and our focus is on the other side as the reflective surface. So my reflective surface is out here, my center of curvature is in the middle here, as well as my focus. And remember, my focus is two times, or is half of the center of curvature. So if my center of curvature is 20, my focus is then going to be 10. Okay, if my center of curvature is 40, my focus is going to be 20. Okay, so on the opposite side. These mirrors are also known as diverging mirrors because the mirror causes light rays to diverge or spread apart. So the light rays will hit the mirror and reflect out away from each other. Concave mirrors were known as converging mirrors, okay, where they would reflect the light rays and then the light rays would all converge on one point, okay, and that point would form the real image at certain locations of the object. Okay, we're going to look at identifying images in a convex mirror now. Okay, the images in a convex mirror are similar to are all virtual images. You're never going to get a real image in a diverging mirror. Okay, these mirrors are used in a number of different cases or a number of different areas in our real life. One would be, say, if you go to a convenience store, you see one of those big mirrors on the ceiling. That is a diverging mirror. Okay, it can cover a large area. Okay, but makes everything really, really, really small. Another place you see this is in your car on your passenger side rear view mirror. It says objects in the mirror are closer than they appear. That's because this is a diverging mirror. Okay, it makes things smaller. It makes them look a lot smaller than what they are, but it allows you to see a larger area as well. Okay, so that's why you use a diverging mirror. Anyways, we still have similar rules when you're drawing in a diverging mirror. The first one is a light ray parallel to the principal axis is reflected as it had come through the focus. Remember, our focus and our center of curvature are located on the opaque side of our mirror. This is our reflected side. This is our opaque side right here with the hatch marks. Okay, and because it's on the middle, in the middle of the sphere, center of curvature, and then half of the center of curvature is our focus. Okay, so if we have a light ray parallel to the principal axis, what's going to happen is our light ray is going to bounce. Okay, is going to pass here. Okay, and it's going to get reflected to an angle that allows the an angle away from the mirror up towards here, but it's going to if I extend this reflected ray, it passes through the focus. Okay, so a light ray parallel to the principal axis is reflected as if it had come through the focus. Okay, so here it is. Locate my focus, and then my diverging um, reflected ray will move away from the mirror, so I can extend my reflected ray that way. The next one is a light ray through the center of curvature reflects back on itself. Okay, so if I have a light ray passing through here that looks like it's going to pass through the center of curvature, okay, I extend it past the mirror. Okay, it comes through the center of curvature, and that reflected ray is just going to reflect back on itself. And then the last one is a light ray aimed at the focus will reflect parallel to the principal axis. Okay, so I see my focus, I see a light ray passing through the focus that looks like it's passing through the focus. I extend it with a dotted line, and then I reflect it back parallel to the principal axis. This is still my principal axis. Okay, characteristics of images in a concave mirror all of the time, no matter what. Okay, there's only one type of characteristic that can happen in a convex mirror, okay, or a diverging mirror. Okay, and if um, we use salt, and because the light rays diverge, the image is always smaller, always upright, always on the other side of the mirror. Okay, located between always on the other side of the mirror, and it could be anywhere along the outside of the mirror. Okay, and it's always virtual. Okay, if we look at it, these light rays do not form or do not converge at a single point in front of the mirror. They all converge if I have to extend the light rays, the reflected rays back in order to get this virtual image. Okay, so always smaller, always upright, always on the other side of the mirror. Take a look at page 500 and do questions on page 501, numbers 1 to 10. This goes over both concave and convex mirrors. We also have a quiz coming up on images and mirrors as well. If you have any questions, let me know.